Hi, I Aziz welcome you to CoedMaster, and in this video I am going to talk about all the operations we can perform on array. So let's get started. So let's start with the first operation, that is search. So let's say we have an array of unsorted elements, that is 1, 3, 4 to 5, and these are the indexes of all the elements. And let's say we want to search number 2. So as number 2 is present at index 3, it's going to return 3. Here we have an array of numbers like 1, 3, 4 to 5. And let's say we want to search number 10. As we can see that number 10 doesn't exist in this array. So it simply returns -1. And -1 is considered as invalid index. Okay, but how does it works? So the idea is really simple. We have to traverse all the elements of an array from 0 to n-1, and in every iteration we have to check if the current number we are traversing is exactly same as the number we want to search or not. And if we found that number, then we simply return the index at which the number is present, and if we do not found that number, we simply return -1. And how can we access the element at specific index? We have to simply use this syntax, square bracket syntax. A is the array and I is the index we are traversing. So this solution we call it linear search because we are linearly searching from 0 to n-1, and the time complexity of this operation is going to be big of n. So this is about when we have unsorted arrays. But what if we have sorted arrays like this? So here we have an array of element 5 and all elements are arranged in sorted order. And let's say if we want to search element 2, then as we can see that 2 present at the index 1, so it simply output 1. So in this type of cases where numbers are arranged in sorted order, we can use binary search. And the time complexity of binary search is going to be big of log of n. Do not worry if you do not know about binary search. We are going to learn binary search in upcoming videos. So this is all about searching. If we have unsorted arrays, in that case we can use linear search to search an element. And if we have sorted array, then we can use binary search to search an element in the array. So in case of normal arrays, we have to write implementation of searching by ourselves. But if we are using array list, then we have all the predefined function available for us. Let's say in case of search, we have function index of, and this function takes object as input. And if it founds the object in the array, it simply returns the index of first occurrence of the element. And in case it doesn't found the element, then it simply returns -1. Okay, so far so clear. So now let's talk about the next operation, that is insert operation. And we are assuming normal arrays as of now. So first thing, what happens when array is full? So as you can see that here array is full and the capacity of this array is 5. And if you want to enter new element 6 at position 6, what happens? This array simply throws out of bound exception, because in normal arrays, if array is full, we cannot enter more elements than its capacity, right? Now what happens if you want to insert at the end? And here we are assuming that we have some empty space to add new elements. So in this case, if x is equal to 5 and we want to enter 5 at index 4, then it's going to simply enter 5 at index 4, and the time complexity of this operation comes out to be theta of 1. In constant time, we can insert any element at the end if we have available space. What happens if we want to insert any new element at the beginning? So let's say we have an array with 5 elements and we have one space left at the end, and if we want to enter number x at position 0, so we are assuming that we have one extra space at the end. So in this case, what happens? We have to shift all the elements towards right to make some space for new element. Okay, and then we simply enter that element at the position 0. So the time complexity of this operation is going to be big of n. And the reason is simple. We have to traverse all the elements from beginning to end and shift all the elements one by one towards right. That is why the time complexity is linear. And similarly, in case of normal arrays, we have to implement all the method by ourselves, all the insert method by ourselves. Okay. Now talking about the insert operation in array list. What happens if array list is full? So in case of array list, we are never going to encounter this situation because whenever array gets full and we want to enter new element, array list automatically grows internally. Okay. Now next is what happens if we want to insert element at the end. So here I am assuming that we have extra space at the end. So if we have extra space, it means the capacity is not full, then we can easily add new element at the end. And after adding this element, now the capacity is full. So the time complexity of this operation is big of 1. In constant space, we can enter any element at the end if we have available space. And what if array is full? So this is where things gets tricky. So let's say we have array with 5 elements and now we want to enter new element 6 at position 6. So what happens in case of array list? It's going to create a new array with size more than the previous array. So it's going to copy all the elements from previous array to new array and then it simply add new element at the last. So let's say we have empty array and we are going to insert all the elements one by one. So for all the n elements, it's going to take big of 1 time. It means constant time. But when we add n plus 1 element in the array, then it's going to take big of n time. And why is like that? Because all the operations till n, it takes constant time. But as soon as the array gets full, it's going to create new array and then it copies all the elements from previous array to new array and then it adds new element at the end. Okay, so in this type of case, we can say that the time complexity of this type of operations is going to be big of 1 plus big of 1 till n elements and then big of n divided by n plus 1. It means it takes constant space. For all the n elements, and if you are going to insert n plus 1th element, it takes linear time. So we can say that the overall time complexity of this operation is going to be big of 1, and we also call it average or amortized time complexity to insert any element at the end. Okay, and after entering n plus 1th element, it again going to take big of 1 time for inserting all the n plus 2, n plus 3, n plus 4 elements, so on and so forth till 2n. And then when you are going to add 2n plus 1th element, then again it's going to take big of n time to add new element. So every time when your array gets full, it's going to create new array, copy all the elements from previous array to new array and then insert new element at the end. So in these cases, we call it average or amortized time complexity. So on an average, it takes big of 1 time complexity to enter element at the end. Now what about if we want to insert element at the beginning? So it's simple. If you want to add any element at the beginning, we have to shift all the elements in the array towards right. So the time complexity is going to be big of n, and it is a linear order of growth. In case of normal arrays, we have to implement all the method by ourselves. But if we use array list, then we get all the functions and methods by default to perform such operations. So this is all about search and insert operations. Now let's talk about the delete operation in arrays. And delete operation works exactly same in the normal arrays as well as array list. So what happens if we want to delete at the end? So if we want to delete at the end, so let's say we have an array and we have x and we want to delete 5 at position 5th. So it's simply going to delete the last element at position 5th. So our size reduces to 4 and the capacity of this array remains as it is. And the time complexity of this operation is going to be big of 1. So meaning we can delete any element at the end in constant time. Now what happens when we want to delete at the beginning or middle of the element? So let's say we have an array like this and we want to delete element 6 at position 3. So in this case, so what happens? We first have to traverse the array from beginning to the position where this element exists, and then we have to traverse this array from the end till this element to shift all the element towards left. So after shifting, the 3 gets deleted and the array looks like this. And now we have extra space at the end. And the size reduces to 4 and the capacity of array remains as it is, 5. And so the time complexity of this operation comes out to be big of n. Why? If you look at this array carefully, you are basically traversing all the entire array. First you are traversing from beginning, from 0 index to 2nd index, and then we are traversing from last index to second index to shift all the elements towards left. So here also, in case of normal arrays, we have to implement all the methods by ourselves, but if we use array list, we get all the methods implemented by Java only. So we can simply use those methods to perform such operations like search, insert and delete. Now before we end this video, let's have a quick recap of what we have learned so far. So we saw how we can do search operations in unsorted and sorted array. If array is unsorted, then it takes big of n time to search any element, and we can use linear search here. And in case of sorted array, we can use binary search, and with binary search, the time complexity of searching is going to be big of log of n. So next we saw how insert operation works in array. So in normal arrays, if array is full, then we cannot insert because we cannot add more elements than its capacity. And what if we have space? So it takes big of one time to add any element at the end. And what about beginning? It takes big of n time complexity to add any element at the end because it needs shifting of all the elements towards right. In case of array list, to enter any element at the end, it takes big of one time on an average. So in some cases, when we add any element at the end, it may cause resizing of array internally. So in this case, all the insert till n takes big of one time, but n plus 1 insert takes big of n time. So after adding all the times for n plus 1 elements, we get average or amortized time complexity. On an average, it takes big of one time to insert any elements at the end. And what if we want to insert any element at the beginning? It again takes big of n because we have to shift all the elements towards right to insert element at the beginning. Now what about delete operation? Delete operation takes big of one time if you want to delete any element at the end, and it simply takes big of n time if you want to delete any element from the beginning, because if we want to delete any element from the beginning, then we have to shift all the elements towards left. So that is why we have to traverse the entire array from last element to the first element. So I hope now you have good understanding of all the operations we can perform on array data structure, along with the time complexity of all the operations. So this is it for this video. Thanks for watching. See you in the next video.